In our last lesson, we went over how to solve systems of equations graphically, and in this lesson, we will go over how to solve systems of inequalities graphically. All right, so with that, let's go ahead and get started on our notes. The set of notes will be about the same or very close to the last set of notes, just because they are very similar in ideas and topics. And so our essential question is going to be, how can I solve systems of linear inequalities graphically? Okay. And to get started, let's go ahead and define what a system of inequalities is. So a system of inequalities is going to be two or more inequalities with the same variables. Right? So if you have an X and a Y in one, you have an X and a Y in the other. If you have a P and a Q in one, you have a P and a Q in the other. They share the same variables. All right. And when we graph, so let's think back. When we graph an equation, the solution or the line that we get when we graph that equation represents every solution that that linear equation has. All right. And when we graph an inequality, excuse me, when we graph an inequality, the solution is represented by an entire region, all right? By an entire region, not just the line. If you think back to when we were solving equations and inequalities, when we got a shaded region dealing with inequalities, this is going to be the same type of thing, all right? So the solution will be an entire region, not a line, and we're going to represent that by shading it in. All right, we're going to shade in that region. When we graph a solid line, oops, where's my, there it goes. When we graph a solid line, that means we graph a solid line if the line is included in the solution, and that's going to be a greater than or less than. Let me get my equation editor thing out. A greater than, I'll put this in red, and it's a solid line if it is greater than or equal to or less than or equal to. Oh boy. Less than or equal to. And the way you get that is you make sure you are in the equation editor for Cami, this division symbol, and you just type out the greater than and then the equal to button right next to it. All right. We graph a dashed line if the line is not included in the solution. So that's going to be when we have just a regular greater than or a less than sign. Okay. So a solid line when we see a line underneath our inequality, and a dashed line when we don't see a line under the inequality. Okay. We shade, excuse me, we're going to shade above the line if y is greater than the expression involving x. So if y is greater than everything on the right side, if we've solved for y and y is greater than everything on that right side, then we're going to shade above. And if we've solved for y again, and y is less than everything on that right side, we're going to shade below. All right, so shade below if y is less than the expression involving x. Okay, solutions to inequations, to systems of equations, are always going to be points, okay, that are in the area where both shaded regions overlap. So if you think back to solving systems of equations, we had points where they intersected because they had those points in common. The same general idea goes for this. We're going to have wherever those shaded regions overlap with each other with both equations, points that fall inside that area, those are what's going to be solutions. So solutions also fall on solid lines, but not on dashed lines, or not where solid lines and dashed lines intersect. Because if you think back, a dashed line does not include a solution, whereas a solid line does. So we will select points that fall on solid lines. But if they happen to fall on the intersection of a solid and a dashed line, we will not select that. Okay. So let's get into some steps for this. And I'm going to make this one in red. So step number one is going to be to put both of these things into Desmos. And then to get the equal part under the inequality, you're just going to type that equal sign, okay? So step one, put them both into Desmos. Step two, it's going to be to identify where both shaded regions overlap. And then step three is going to be any point that falls in the overlapping shaded region or on a solid line is a solution, okay? You absolutely cannot have solutions on dashed lines. All right, so let's look at a couple of examples. I'm gonna open up my Desmos and split screen with my notes, the way you all should be doing as well on this part and on your practice. Example number one, we get y is greater or is less than 2x plus 5 and y is greater than or equal to negative 1/2 x minus 1. So on my Desmos, I'm going to go ahead and turn on projector mode and the arrows. You always want to turn those on. And I just like seeing the reverse contrast. That's optional. You don't have to do that, but always do those first two. When we type these in, you're going to see that we've got some examples out here. And I'll type them in just so you can see what that whole process looks like. Y is less than 2x plus 5. This is what our first one looks like. And then we have y is greater than or equal to negative 1/2 x minus 1. All right, so I'm going to turn off one of these graphs to start. What you're looking at here to the left of these examples, we have one graph. The first graph is highlighted. That's what we see. And then the second graph we see is the second inequality. And then this last graph over here is both of them together. This is what we're going to be looking at when we try to find our solutions to a system of inequalities. All right. Now look, when we pick these, we have to pick areas. Let's look at this Desmos here. We have to pick areas that are in this shaded region where the blue and the orange overlap, this kind of yellow, light yellowish area, or mango maybe, if that's the color you want to use. We're going to pick points that are in this area, okay? So let's see, does this point work? This point does fit in both these shaded regions. What point would this be? This would be 1, 2, 1, 2, 3. That would be 2, 3. So that's a possible point. Actually, I want to do that in this pink color. 2, 3 is a possible point. And then let's just look at another one. Let's see if we pick this point here. This would not be a possible point. What is this? 5, negative 10. This is only in the shaded region of one of these inequalities, so that can't be a solution. But if we pick anything up here, that will be a solution. I'll pick one more, then I want you all to pick two more as possible solutions. If we look at starting at 0, let's see what's the closest we can get to this line. Let's go 1, negative 1, 1. That's a good one. That's right about here. That is a solution. So I'm going to type that in. Negative 1, 1. Oops. Comma. All right, there goes two solutions to this system of inequalities. I want you to pick 2 more points that are possible solutions, okay? Let's look at this next example. This next example, we're going to go step by step and see what we get. My first step is to type both of these equations into Desmos, and you might be able to copy and paste. Let's see. Copy, paste. Nope, you cannot copy and paste. It does not work. So you want to make sure you type these and then make sure that you type them right. X plus y is greater than 2. Right, there goes 1. Now let's type in this next one. Negative 4x plus 2y is less than 8. Right? So we see we've got 2 dashed lines. We won't pick anything that's on a dashed line as a solution, but we have all these possible points to pick for a solution. You go ahead, I'll pick 2. I want you to pick 2 as well. This point here is good. This is going to be 2, 2. That's going to be a point that I'm choosing. And let's see, let's go with this point here. What's this? 4, 6. That's the other point I'm choosing. So now I want you to pick 2 more points that are solutions, okay? I've picked 2. I want you to pick 2 more. Let's look at this next example. Number 3. Number 3 is 3x minus y is greater than or equal to 2. And then our next one is y greater than 3x plus 5. Ooh, that looks weird. Did I type that right? 3x minus y is greater than or equal to 2. Yep. And then the y is greater than 3x plus 5. Yep. You always want to make sure you're double checking to see if you've typed things correctly. And I have typed these things correctly. And what I have is a set of parallel lines, a pair of parallel lines. These things will not cross at all. They won't ever cross. We don't have any area where our shading is overlapping. So since that's the case, this is going to be no solution. All right, no solution. We can't ever have a solution to a system of inequalities or equations where our lines are parallel. These things do not overlap, so we can't do anything about that. That's going to be no solution because these things are parallel and shaded away from each other. All right, number 4. Number 4 says, given the system of inequalities above, which of the following are solutions? So they gave us a system and then they're giving us points to check. I'm going to do 1 or 2 of them for you. Then I want you all to do the rest just so you all can get some good practice. So my system is y is greater than or equal to negative 4. And then it is x is less than 8. Whoa, there. X is less than 8. Had to zoom out of my Desmos graph a little bit. All right, so when we're doing this, we're only picking answers that are in the shaded region. So let's look at this first answer choice, negative 1, 3. Negative 1, 3. Here's my 0 here. So negative 1, 3 is going to be negative 1, 1, 2, 3. That will be in the shaded region. And the way you probably want to do these is to type them into Desmos and see where they find. Negative 1, 3. That fits. That falls in. Oops. Close the parentheses. That is a solution. I'm going to put a little circle around it. Put circles around the ones that are solutions and maybe draw a line through things that aren't solutions. So if that's not a solution, draw a line through it. Let's actually check that one to see if it is. 10, negative 1. 10, comma, negative 1. This falls in the shaded region of one of our inequalities, but not in the shaded region of both of them. So this one is not an inequality, okay? I want you to go through, check the rest of these, And when you're done working on the classwork, or when you're done, go ahead and fill out the summary here. We've gotten you started. It says I can solve systems of two linear inequalities in two variables graphically by. Go ahead and just summarize the process. Once you finish with these example problems, summarize the process in the summary below, and then move on to the classwork, okay? When you're done with that, let me know. If you have any questions, please ask, and I will do my best to help you.